are millions of people around the world. Math is everywhere. Everybody's dealing with math. What will you do if you don't know math? Well, here's our friends Ivan and Moises going to teach you something about math.
What's up, everybody? This is me, Ivan, along with my bro, Moises, and we're here to talk about remainder theorem.
The remainder theorem is useful for evaluating polynomials at a given value of x, though it may not seem so, at least at first.
This is because the tool is presented as a theorem with a proof, and you probably don't feel ready for proofs at this stage in your studies. Fortunately, you don't have to understand the proof of the theorem, you just need to understand how to use the theorem.
The remainder theorem starts with an unnamed polynomial p of x, where p of x just means some polynomial p, whose variable is x. Then the theorem talks about dividing that polynomial by some linear factor x minus a, where a is just a number. Then as a result of the long polynomial division, you end up with some polynomial answer q of x. The q standing for the quotient polynomial and some polynomial remainder r of x.
So our first example is p of x equals x cubed minus 7x minus 6 divided by 4. So first step is to substitute positive 4 to all the x variables. Then multiply, get 64 minus 28 minus 6. 64 minus 28 minus 6 is equivalent to 30. So the remainder is 30.
Did you know that polynomials are expressions of more than two algebraic terms, especially the sum of several terms that contain different powers of the same variables?
So in our second example, we got p of x equals x squared plus 4x plus 9 divided by x plus 3. First step, substitute negative 3 to all the x variables. So you get negative 3 squared plus 4 negative multiplied by negative 3 plus 9. Get 9 minus 12 plus 9. 9 minus 12 plus 9 is equivalent to 6. So you get 6 as your remainder.
So we got a proof for the remainder theorem. We got p of x equals x cubed minus 6x squared plus 11x minus 6. Prove that x is equivalent to 1 is a root of p of x. So our solution would be p of x equals x cubed minus 6x squared plus 11x minus 6. So substitute 1 to all the x variables, then multiply, and then you get 1 minus 6 plus 11 minus 6 equals 0. So p of 1 is equivalent to 0, which implies that x equals 1 is the root of the polynomial p of x, and x minus 1 is a factor of p of x. Therefore, if we were to synthetically divide through p of x by x minus 1, we should get a new smaller polynomial and a remainder of 0. Well, that's the wrap on remainder theorem. Hope you learned something, enjoyed the whole video. Again, this is me, Ivan Philipp Frejoles, with my friend Moises Dagani. And we are out.